David, thank you so much for hopping on.
Hey, Zaid, thanks so much for having me. Really appreciate it.
Absolutely. Appreciate you taking the time. I'd love to dive into the nitty gritty things here in a moment, but if you could just kind of explain it to me like I'm five, what is it that your company does?
So this little protein you see behind me, we think is going to change the world. It's
I
the
love
most
that.
interesting little, yeah, no, we're really in love with what we have back here. It's a protein that targets something called soluble TNF. Some of the readers may have heard about TNF. They're the largest selling, the anti-TNF drugs like Humira, Remicade, Enbrel, largest selling drugs on the planet, but they're stuck in autoimmune disease, things like rheumatoid arthritis, Crohn's, psoriasis. They sell close to 50 billion a year, all of them. And they have a little problem, and that is that they immunosuppress patients and they cause problems in the brain. And our little protein back here, it's a next generation TNF inhibitor. It does what those do, but it does it better. And it does it better because it's not immunosuppressive, it's immunosupportive, which means that we can use it in a lot of applications like Alzheimer's disease and other areas where you have chronic inflammation. So that's what we're pursuing in the clinical trial. We're taking this drug, it's in mid-stage clinical trials in Alzheimer's. It'll do treatment-resistant depression, but has applications in ALS, Parkinson's, multiple sclerosis, and on and on and on. It's got a wide use of applications.
Yeah. You mentioned Alzheimer's, and that's where I want to go next, because you recently had some exciting preclinical results for XPro, showing how it can help prevent Alzheimer's related pathology with, traumatic brain injuries and different things like that in mice. But what can you tell me about those results and what it can mean in humans though?
So we've actually completed a phase 1 trial in humans, and we have a lot of human data now. And what we show is that we decrease neuroinflammation dramatically. And when you do in the brain, about 50% of the immune cells in the brain are immunologically active, and they start doing their job again. They start to repair the brain. They start to repair what are called neurons and synapses, which is where the memories are stored and where the information is transferred. And when you repair that, actually you can repair, we see remodeling, which is repair in the brain of a 70-year-old patient, which means that we think we can stop cognitive decline, actually maybe improve it. And if you can do that, that really halts the disease of dementia. So that's our goal. It's different than what's been done in the past, because if you look at the trials that have been done in the past, they've all been targeting what are called amyloid and plaques. Everybody's familiar with that. There's been some drugs that have recently been approved in that area, but it doesn't stop the course of the disease. It just changes the downward slope. It's a little less downward, but you still decline. Our goal is to flatline them, just flatline the decline. And by getting rid of neuroinflammation and doing it the right way, it's really critical. You have to do it the right way. The brain starts to heal itself. And, we had patients in our phase 1 trial. It is early and it is an unblinded trial. But we had patients that were on the drug that, we had, for example, one patient who was a professor, couldn't remember students' names, couldn't remember his mathematical formulas. And after being on XPro, he went back to work. He was able to remember names and so on. And why is that? Because the neurons, which is where the memory is stored, that's where, for example, this mathematical formula is stored, wasn't gone, but we helped repair the synapses so he could start to recall those things again. And we're running a phase 2 trial now. It's open in Australia. It's open in Canada. It will be open in the US towards the end of this year. That trial will be completed, and the data will be out towards the end of next year. And that trial is going to tell us what we do with cognition. Do we flatline it? Does it do better than the existing drugs, or does it not work at all, or does it improve? And that'll be a major milestone. If we do what we think we're going to do, it'll change the world.
So I want to understand something here. And by the way, we do have your presentation deck. So if you want to refer to anything, because I'm a visual learner. So if you ever want to refer to anything, feel free to ask for that and we can do it. I don't want to simplify things, but you mentioned something interesting about the person who was able to go back to work, right?
Sure.
Am I correct to assume that, hey, when you're dealing with Alzheimer's, the information that you have that you can recall is still in your brain, but you don't have access to it? And that the drug you're working on kind of unlocks the door so that you can gain access to it? Am I correct in understanding? I know I simplified it, but...
No, it's a very, very good question. It depends on where you are at the disease, right? So you have two things. Alzheimer's is really a simple disease. We've made it complicated. You have two things going on. You have the neurons, which is where the memory is stored. That's where your girlfriend's name is. It's where your mother's name is, for example. That cell, if it dies, it's lost. That memory is lost forever. Think of your computer. You have the memory. That's where the memory is stored. If the memory blows up, you lost that memory. And then you have the synapses, and those are the wires that transmit the the memory, right? So what happens in Alzheimer's disease early in the disease is those wires break, right? And they go first, and then the neuron dies. So if you can catch the disease early, like we did with this fellow, we repaired
Yeah.
the synapses, the memory wasn't lost. And so he was able
Got
to,
it.
but once that neuron is gone, we don't resurrect and rebuild neurons. So like
Got it.
anything, you want to catch the disease early. If you get cancer early, you have a better chance versus if you catch it late. In Alzheimer's, if you do it late, it's too difficult. So
Got
actually,
it.
it's a good thing for investors. If they're looking at companies doing Alzheimer's trials and they're in the middle to the late stage of patients, I'd say good luck.
Really? Okay. Well, let's talk about someone else that might be in the market, right? We've talked about Alzheimer's drugs. I want to talk about the developers and what kind of generally happens in the M&A space in the area that you're currently in. Any insight from you on that?
So, we're a company with two platforms. Given the time, we only have, there's the pipeline chart. We're talking about XPro, which is the Alzheimer's drug. It's the next generation TNF inhibitor. And then we have INmune. And, in the neurodegenerative space or the CNS space, there's been a lot more activity recently, especially with the Eisai Biogen news and what's been going on with Eli Lilly and their drug to near approval. We haven't had as much success in the oncology space, in the CNS space as we've had in the oncology space, but that's changing. I think the golden age of CNS development, it's going to look like the oncology space in the next decade, and it's not as crowded as it is in the oncology space, and there's a lot of innovation going on. So for example, in our area, we look at neurodegenerative disease as an immune dysfunction. A lot of people have looked at it as a neurologic disease, but if you look at it as immune dysfunction, it's like immunotherapy in cancer, right? We use now the immune system in cancer to make big differences. Well, we're going to do the same with the brain. And we haven't done that yet. So I think we're kind of leading the charge in that area. We're mid-stage in our trial, and there's not many people that are using as many biomarkers as we are, nor are there many people yet that are really looking at the immune system of the brain, but that's about to change.
With so much, so much money goes into R&D and the expenses and making sure you get approved by regulators, everything else that goes into it. It's not cheap to do what you're doing. So if you don't mind me asking, what's the financial health of the company look like? More specifically, the type of cash runway. What do you have?
So good question. We're really proud of our capital structure. We only have 18 million, little under 18 million shares outstanding, and 40% is held by insiders. I'm one of the co-founders. So there's three founders, and there's a company called Xencor. Combined, we owned over 40%. And we have over 50 million in cash. It's enough through 24. And when a patient or a person hears about Alzheimer's trials, I think, oh my God, long and expensive, right? But these trials are not. These trials are short and less expensive. And why? Because we know the biology that we're targeting, which is the TNF I mentioned. And when you hit the biology directly, and you can measure through biomarkers, you can measure the biologic change. And that's like a cancer trial, right? And so these trials are shorter and cheaper than what people are used to. And it's the reason why we can move through the clinic faster, and we can do these for a lot less money.
When it comes to, investors, right? You brought that up and how investors may think, oh, Alzheimer's, it's a long track to go and different things like that. We've seen so many crazy things in the stock market in terms of short squeezes and different things like that. The folks that might be betting against your company, if you're aware of any, what are they kind of getting wrong about the story itself? What thesis would somebody have to go short your company and not believe in you having success?
Alzheimer's is an area that's had nothing but failures. And why is that? Because they've been targeting the wrong thing. They've been looking at the amyloid and plaques, which doesn't kill neurons and synapses. And they've been doing the same thing over and over, or they run, let me just say, bonehead clinical trials. They skip phase 2, go to phase 3, they do an unblinded phase 2, et cetera, et cetera. And so they fail. We're doing this, it looks like an oncology trial. It's short, it's blinded, it's randomized, it's really going to test if the drug's going to change cognition. And, I think that they're short because of that. So our cap structure is interesting. It's only common shares outstanding. There's no warrants. There's no convertible debt. There's nothing funky. It's what you see is what you get. We're all retail investors. And we have about 1 million shares short. And I think the short is all institutional. I don't think anyone retail would be short our stock. It would be really silly for them to do it. But it must be all these algorithmics, institutional shorts. So if you look at I like to say that if you look at our institutional holding, it's actually negative because we have a little bit of institutional holding. It's small, but our short interest is larger. And so I deduct that from our institutional holding and it makes it negative.
Yeah.
But we've got a great shareholder base, very loyal, long-term shareholders. We want to build on that. We manage our capital structures and our capital very efficiently. I take the most dilution, so I'm very sensitive about that. But we're trying to solve a big problem here. And if we do, I think it's going to be a monumental change. And that's why I say, change the world. It sounds ridiculous, but I really believe that if, we're sitting on a next generation TNF inhibitor, we know TNF is a great target. And if you do it better and you do it in things like Alzheimer's, where neuroinflammation plays a big role. I mean, just type neuroinflammation and name the disease in Google and you'll find out information. But if we do that, I think we could be sitting on a huge drug franchise and it could change the lives of millions and millions of people. And so the opportunity is just enormous for us. I
do want to get to a couple of questions from the chat. AI has been the talk of the town ever since ChatGPT came out to help me ace my homework, if you will. Are y'all using AI in any shape or form? If not, do you plan to, or is it kind of not something that would be an asset to you?
We use it. We actually use it. We get so many data points through our biomarkers that it's so much data, and then to correlate it, we use AI, and it really gives us really interesting data. Actually, we published some information on AI where it showed that all of the data, what we call proteomics, we had MRI imaging of the white and gray matter, and then we had blood from the CSF. And we took all of that and threw it into AI, and it really showed that, patients in our phase 1 trial normalized, they all kind of collaborate, and they looked more like a normal population. So AI is very helpful. It's a way to analyze just enormous amounts of data and, help give direction on what's going on.
One last one, I'll turn it over to you here. We've got Raz from the chat asking what the average patient age is, and is it lifelong therapy? And especially what I'm interested in is kind of tying into that question is I know you mentioned that, hey, you kind of decline the rate at where the, Alzheimer's may increase, if you will, but is it kind of like, hey, it's a steady decline, or you kind of mentioned the flat line as well?
Yep. So patients who have Alzheimer's, they decline like this. Right. Patients who have neuroinflammation with Alzheimer's decline more steeply. In other words, if you have elevated neuroinflammation, your decline is more rapid. Okay. If you take the average, it's like this. If you take Biogen's drug, it's maybe a little bit better. It's about a 4 to 6 month difference. Our goal is to flatline the cognition. So cognition, you do not decline. So it's not a part of your disease. And, our average age is about 70. These patients are in their somewhere in the 70 age range. The treatment is easy. It's a once a week sub-Q injection. It's just a small protein, so it's not complicated like an infusion or anything like that. It's like an insulin shot. It's just, once a week. And yes, you would take it for life. It's, your neuroinflammation comes with age. It comes with lifestyle. It comes with everything. Inflammation, chronic inflammation is responsible for more than 50%. It's attributable to more than 50% of deaths. Name the disease. Wow. It's a huge market. It's the reason why the TNF inhibitors are so huge, and they're stuck in autoimmune disease. We can now take that TNF inhibitor and go to cardiac disease, cancer, neurodegenerative disease, metabolic disease, where they can't. So it means this franchise has just an enormous opportunity based on the drug we've designed. And that's why we're so excited. It's why we own a lot of stock. It's why we want to continue to own a lot of stock. And I saw someone in the chat say that, they pulled up the inside ownership at 9%. That's not correct. They need to look a little closer. It's 40%. Okay. So whatever system they're looking at the wrong system. But, look, all I'm asking is look at our company. Of course. It's the most interesting company you've never heard of.
Yeah. Well, I mean, our chat has been quite active, like you mentioned, and I hope you don't mind. I've got one more here because
I love it.
So timeline, right? I know you're a publicly traded company. There's so much so that you can say, but I'd love to know timeline and insights in terms of what's next. What can investors, because you already have them in the chat, Leon is one of them, and potential investors. What's the timeline of what's next on your company here?
Yeah, so we have a number of things. I'm only going to talk about XPro. We have another platform. That platform is going to have data this year and next year. But for XPro, I think the milestones for the business is obviously open the US, which is we have an FDA hold that will come off of. So it opens. We'll continue enrolling patients in Australia, Canada, probably open one other international jurisdiction. All those patients, that trial will be complete and the data will be out in the fourth quarter of next year. And then we have a treatment-resistant depression study that will start when the FDA lifts the hold. That's half funded by the NIH. And that is, you're talking millions of patients with treatment-resistant depression. It's a phase 2 study. It's run by two of the greatest people, the researchers in treatment-resistant depression at two top universities. And, those are the big milestones for us. Other than that, you might see something else with potentially some corporate partnerships or some other things going on. I'd never really like to promise much in that area, but with the platform that we have, it has a lot of applications and there's a lot of interest in what we're doing.
Gotcha. Appreciate you. This has been a wonderful conversation for me, and we've gone a bit over time, and I apologize for that, but I've learned a lot. I've been trying to work out, so I thought protein was just great to build muscles, but obviously there's a lot more that it can be an asset to, especially in the brain. I've definitely loved what I've heard, but I do want to still give you a chance to cover any topics that I may not have brought up. The floor is kind of yours to talk to our investors here.
Yeah, no, KB brought up something about rheumatoid arthritis has a high incidence of Alzheimer's. I want to end on that because this is the reason we're using TNF. Patients who have rheumatoid arthritis, they're TNF factories. They just produce it in their joints. It's why, their joints hurt. And if they take a TNF inhibitor, patients who have elevated TNF that have rheumatoid arthritis have an 800% increase in the chance of getting Alzheimer's disease compared to the normal population like you and me, innate.
Yeah.
But if they take a TNF inhibitor and only a TNF inhibitor, not a JAK inhibitor or any other kind of anti-inflammatory, their incidence of Alzheimer's disease goes down 60% compared to the normal population. So TNF clearly plays a role.
Yeah.
The problem is they can't use those drugs because they're immunosuppressive, and you don't want to immunosuppress a 70-year-old patient.
Yeah.
But our drug is actually immunosupportive. And also because half the cells in the brain are immunologically active, you don't want to immunosuppress them because they can't do their job of taking care of the neurons and synapses. But if you get rid of the neuroinflammation and you do it well, by supporting those cells, immunosupporting them, the brain does great things and it repairs itself. And that's what we're doing. It's a really cool, it's the neatest little drug back there. And we plan to do our best to take it to market.
I absolutely love that it's your background there. Thank you so much. That is David Moss, who is the CEO of INmune Bio, ticker INMB. David, thank you so much for your time. And I really do look forward to our next conversation.
Please, I really appreciate it. Thank you so much for listening to me.